In this lesson, we're going to look at solving indirect proportions. So by the end of this lesson, you should be able to identify indirect proportions and solve indirect proportions algebraically. So indirect proportion, what is an indirect proportion? So in an indirect proportion, this graphic gives us a good visual. So normally, if you're thinking of a direct relationship, if you have a larger fish, the larger fish is going to be in the bigger bowl. But in this particular example, and I've just taken it as an image, we can't really do any math with it. We've got the small fish in a large bowl and the big fish is crammed into the little bowl. They are inversely proportional. They probably shouldn't be, but that's what this graphic happens to be showing us. So I thought it was a really kind of good way to give us an image that kind of sticks in our head, hopefully. So when you have an inverse relationship, one quantity is small and the other quantity, one quantity has decreased while the other has increased. So the size of, so for here, the size of the fish has decreased, but the size of the bowl has increased as compared to what was in the first bowl. So we're going to do some math examples that relate to this. The first one we're going to look at is doing an install. So if it takes a crew of 4 people 21 days to install and finish a prefabricated home, how much longer would it take if there were only 3 people on the job site? Now let's just take a minute and use some logic. So at the beginning here, we have 4 people. So we've got more people. And that we know that if there's more people, it should take us less time. All right. As compared to over here, we have 3 people. So 3 people, we've got less people, which should give us more time. Okay, that's in our ideal scenario. More people, less time, less people, more time. Now, of course, I know there's a number at which there's too many people and it doesn't get any faster. We're just assuming everybody can work the same rate. All right, so this kind of gives us a good idea. So let's now do some math. Now to set these ones up, we can set them up like a ratio, but the ratio of the number of people it will take is going to be opposite to the amount of time it's going to take. But I'm going to show you another method in order to set these up. So they're installing the same house. So I'm going to put my equal sign under the house because I know that's the common ground between these two relationships. I know the time, the total amount of time it takes to build this house has to remain the same whether there's 4 people doing it or 3 people. So the number of man hours that we're going to build for. So if I have 4 people working on this job, I'm going to build for each person 21 days. So that means we have 84. I'm going to actually get rid of that equal sign just because I think it'll give us some trouble later. That means we have 84 days worth of work. Okay, now over here, if I have 3 people times X number of days, that still has to be equal to 84 days of work. It has to remain the same. The job hasn't changed, okay? So let's take those 84 days of work and we're going to split it between 3 people. So what we really end up with for an equation is 84 is equal to 3x. You know how to do this math. We're going to divide by 3. And we find that x is equal to 28 days. So if I have 3 people, split the work between 3 people, we have 28 days of work. So you'll notice rather than using our colon to set up a ratio or a division to set up a ratio, indirect proportion uses multiplication. I can't write very well on here. So indirect proportion uses multiplication, not division. Okay, and I'm going to give that to you on a summary slide at the end. But indirect proportions, they're going to be set up using multiplication and not division. All right, let's keep going. Let's use the words fast and slow, and I want you to write the following ratios. So, speed ratio, ratio of A to B. So gear A is a fast gear. So it's fast, to gear B, which is a slow gear. Now we're going to use size to write the size ratio. We're just going to use big and small. So gear A is small, and gear B is large. These two ratios, if we look at them, the small gear has a higher speed. It's going faster. So this is indirect. Where the slow gear, less speed, but it's bigger. So they're working opposite of each other, and we're going to do some calculations that involve that. So when we're looking at gears or pulleys or connected belts, we're going to find that the ratio between sizes or teeth and the speed at which something is moving is an indirect relationship. The small one is always going to go faster, and that's because for every one turn of this large gear, the small gear is moving several times. Now let's look at an example. So here it says gear B has 5 teeth and it's driving gear A, which has 8 teeth. I want to know the gear ratio of the driven gear to the driver gear. So let's figure out which one's the driven gear. Well, B is driven and A is the driver. So it just helps us to make sure we get that order right. What is our gear ratio? Well, let's look at the number of teeth. B has 5 teeth to A, which has 8 teeth. Now if you think of the speed ratio, remember from before, the small gear is going to go fast. The large gear will move slow. And that's because for every one tooth that this gear moves, it'll go 8 teeth going all the way around. This gear only has 5 teeth, so for every one turn of gear A, gear B is going to go about 1.5 times. So it's moving much faster than the other one. So our speed ratio, instead of being 5 to 8, is going to be 8 to 5. And we can prove that if we want by doing some reduction with part C. So now we have a math problem. It says if gear A is turning at 250 revolutions per minute, that's RPM. If you're not familiar with that, what is the speed of gear B? So we can do this two ways. Since we have our speed ratio, we could set a direct relationship up with that. But what I like to do for gears is I always say the teeth, or the size, is indirectly proportional. So we're going to use multiplication. Teeth is indirectly proportional to speed. So teeth times speed is going to be equal to teeth times speed. So this is gear A, and this would be gear B. Okay, so the teeth for A times the speed of A has to be equal to the number of teeth and the speed of B. And that's because if A goes 10 revolutions and it has 8 teeth, that means it's moved a total of 80 teeth. Well, we can use that to figure out how many turns would B have to go to have moved 80 teeth as well. So that's where this relationship comes from, and it's even easier than using these ratios for doing some solving. So we're going to use that to calculate it. So we're going to start out with gear A. Gear A has 8 teeth, and it's moving at a speed of 250 RPM. It's going to be equal to the teeth in B, which is 5, times, I'm going to use S for speed. Or I'll just write speed out, I guess. Okay. So 8 times 250. So in 250 revolutions, it's moving 2,000 teeth times RPM. That has to be equal to 5 times the speed. Now to get speed by itself, we're going to divide both sides by 5. And the speed is equal to 400 RPM. All right. So we'll find, let's do a logic check. We saw before that the small gear was moving faster. Well, A is going to 50 RPM, B is going at 400 RPM, which is much faster. So that matches up with the logic that we saw earlier. Let's do another example. Gear A has 10 teeth and it's driving gear B, which has 12 teeth. What's our gear ratio? So our gear ratio, the driven gear is B and the driver gear is A. So this is a 12 to 10 ratio, or we can write this as a 6 to 5 ratio. Our speed ratio is going to be opposite of that. It's going to be a 5 to 6 ratio. So we just flip the ratio. So the larger gear is moving slower, so it has the smaller speed number as compared to the smaller gear has a larger speed number because it moves faster. So again, I couldn't be bothered changing numbers. Gear A is turning at 250 RPM, so what's the speed of gear B? So in order to figure this out, let's do the same as we did before. So we have teeth times speed is equal to teeth times speed. And let's plug in the information. So A has 10 teeth and it's going at 250 RPM is equal to 12 teeth times X RPM. Okay, so this is, I'm going to label these. This is A, this is B. All right, so we have 2,500 is equal to 12x. So 2,500 divided by 12 equals, well, the 12s cancel out, so x is equal to 208.3. Now you'll notice we put RPMs in here, so our speed that we get out is also going to be RPM. The units will always match. Okay, whatever the units are you put on one side, you want to have matching units on the other side. So the speed of gear B is 208.3 revolutions per minute. Now you could round that off to 208 revolutions per minute, either way. So not too bad. Again, we're setting up like our ratio. I like to think of it as before times after. Before scenario multiplied together equals the after scenario multiplied together, and that's kind of how I keep things straight in my head. If you want another way to do this, I can give you another method, or if you want to make a video and show me how you like to solve these, I would always be welcome to kind of looking at how you do something. Just another couple quick questions, then we'll finish this section off. A pulley wheel with a diameter of 2 3/4 inches is rotating at 125 revolutions per minute. If the motor is rotating at 275 revolutions per minute, what's the diameter of the small pulley? So in this case, we know that this wheel is 2 3/4 inches and its speed is 125 RPMs. Here's our motor here, and it's going at 275 revolutions per minute, and we don't know the size. Okay, we don't know what this size happens to be. So we can solve that quite easily. We're going to take one wheel and set it equal to the other wheel because the distance this belt moves, so if it moves half of a turn around this wheel, it's going to move this little pulley here, the equivalent distance, and it may move several turns. So 2.75, easiest just to switch them to decimals, times 125 is equal to the speed of the motor, or the size of the motor pulley. I'm going to let's call this A, and I'll call this one B. So B size times 275. Now we want to get rid of this 275, so we want to move it to the other side. So in order to do that, it's multiplying, so we're going to do the opposite. We're going to divide. Whatever we do to one side, we do to the other. We have to keep them balanced. So these cancel. And size of B is equal to 2.75 times 125 divided by 275. And that leaves us with, I had a total brain moment there, and I should be able to do that mental math, but it just wasn't coming. 1.25 inches is the size of pulley B, or the small pulley. Okay, or you could write it as 1.25 if you want to match fractions like we had before. So they're all pretty straightforward questions. So the last thing I want you to do, we're going to give you a quiz, and in your quiz you will have a mixture of direct or indirect, and you'll want to be able to identify which ones are which. So I always say, do the thumb test. If one quantity goes down and logically the other quantity would also have to decrease, you know you have a direct relationship. Or if one quantity increases and the other quantity increases, then you know you have a direct relationship. So they're both moving in the same direction. When you have a direct relationship, we set up our ratios like two fractions. Set it up like two fractions equal to each other. So we're going to set them up with this fraction or this division line. Okay? If you have an indirect relationship, one quantity increases while the other quantity decreases. So use the thumbs up, thumbs down method if you want. I find it's a really good visual, and I'll often see people doing it when they're doing tests. They'll see their hands going, and that works. It helps for people to be able to kind of see what's happening. So more workers means less time. So thumbs up, thumbs down. That means we have an indirect relationship, and you'll set those ones up as multiplying. So instead of two fractions, we change our fraction line for a multiplication sign, and we set them equal to each other, and then we solve. So very, very simple relationships to set up. And now that we've got this done, we'll move into percentage next class.